Hey everyone, this is Ragstad here. I am going to be sharing with you our next lesson that we didn't get to cover in class today, and that is experimental design. And in your notes, you probably have section 1.6, I believe. So I think I can cross that out. And today's date should be August 29th, 2024, if you are watching this on that date. Okay, so I'm going to give you some notes today and some examples. Please put these in your notebooks and make sure you put an entry in your table of contents so that you are all good to go for your notebook check tomorrow. Okay, so moving on. Yesterday, we talked about the cycle of scientific enterprise. And as a review, in this scheme, we have a theory, which is the best explanation at present. We have a bunch of facts that back that up. Our theory enables us to make a hypothesis, which is an informed prediction that tells us how that theory, or asks the question how that theory might work in a different situation. Today, we're going to focus on the experiment part because the experiment is what tests whether or not our hypothesis is correct. And if our experimental results show that our prediction was correct, then our theory is strengthened. Whereas if our experimental results do not give that result, then our theory is either weakened or we may have to revise the theory in the future. So, for example, in one of the classes, somebody suggested, well, could we test the theory of gravity, which has an equation that goes with it that tells us how much force something experiences based on its mass. So the mass of the Earth, say, and the mass of the object being pulled towards the Earth. Those are the two masses divided by the distance between them squared. And so somebody said, well, if this is the theory, then a hypothesis might be that does gravity pull less strongly on the top of Mount Everest because the top of Mount Everest is farther from the center of the Earth? And likewise, does gravity pull strongly, more strongly at the bottom of Death Valley because that is closer to the center of the Earth? And we could test that by taking a person, or even better, taking a 20-pound weight to the top of Mount Everest and putting it on a scale there, and to the bottom of Death Valley and putting it on a scale there, and seeing if it registers differently, if it has more or less weight. That is the example of an experiment. Okay, so we're going to keep that example in mind as we talk about how we're going to design the experiment now, because we will see that there's such a thing as a well-designed experiment and a poorly designed experiment. And honestly, when we're doing an experiment and our results do not turn out the way we expect, our first conclusion should not be that the theory was completely incorrect. It should be that maybe our experiment should have been better designed and we can go back and retest it in a better way. All right, so let's do a little bit of review. Now, you guys are pretty mathy, so you probably know that this is the coordinate plane. You probably know how to graph an equation on this. You need to remember that the y-axis is the one that goes up and down, and the x-axis is the one that goes from side to side. This is the whole coordinate plane that you would see in a math class. However, in science class, we're probably only going to be dealing with quadrant 1, which is both variables being positive. Quadrant 1, that's usually what we're dealing with, not 100% of the time, but usually. Okay. Okay, so what is a variable? So I'm sure, dealt with variables in math class. And in science class, we will likewise be dealing with variables. They might have different names than you're used to. So an explanatory variable is the thing that you want to test. So in our example about gravity, the thing that we wanted to test is how much weight is affected in different regions of the Earth, right? This is the thing that the experimenter has control over. So in our example, the experimenter has control over how much mass we're going to test. Are we going to use a 20-pound weight, a 10-pound weight? Are we going to use a variety of them and graph all the results of them? Can we use a 5-pound weight, 10-pound, 15, 20, and go all the way up? There are several different names for this that we could use. The one that our book uses the most is called the explanatory variable, because that's the thing that you want to explain. That makes sense, right? You may have heard of this as the independent variable. That is because this variable does not depend on anything other than what you yourself decide. Okay, and this is the one that we always plot on the x-axis. So when we're plotting dots of data, we go over the x-axis. The explanatory variable, the independent variable are the ones that we put on the x-axis. Okay, so I have this written here. I also have all the types of variables written in my chicken scratch, poorly written handwriting if you want to copy it from here. So the next kind of variable that we could test is the response variable. This is the variable that you are taking measurements for. This is kind of like the result of the experiment. It's what is in response to what you tested. So the results of the experiment, the thing that you measure, it's also known as the dependent variable because it depends on what you put into the system, okay? And that's what we plot on the y-axis. So in our example experiment, because we all came up with this together, the dependent variable would be how much weight registers on the scale that you use either at the top of Mount Everest versus the bottom of Death Valley. So mass would be our explanatory variable, weight would be our dependent or response variable. Now, lurking variables. You guys already had some great ideas for this. These are things that unintentionally affect your experiment. So as we were discussing in class, the first suggestion was to send a person to the top of Mount Everest and to the bottom of Death Valley and take their weight there, because you would make the assumption, oh, the person's going to weigh the same regardless. But that's not a good assumption, right? Because if you take the trouble to climb Mount Everest, you might lose weight just because you exerted so much effort and you're breathing more poorly because there's not a lot of oxygen up there and you're not eating the same things. Like there's all these other factors that can mess with the results of our experiment, because really a really good designed experiment only tests one variable at a time. That's the only way you can make a good conclusion about your experiment. If you throw too many things into the mix, you don't know what caused it. You can't say whether the results of your experiment are due to your explanatory variable or something else, which would be a lurking variable. So by not using humans in our gravity experiment and instead using a standardized 20-pound weight or whatever pound weight that we know isn't alive, it isn't eating, it isn't doing exercise and gaining and losing weight because it's alive, that's a much better thing to use. It has fewer lurking variables. So a really good way to design an experiment is to minimize your lurking variables. And this is also called a control, right? You want to control as many things as possible. So anything that stays the same throughout your entire experiment is called a control. So if we're using the same weight, the same mass, right? The same 20-pound mass throughout all the experiment and testing it in different locations, that is a controlled variable because we know it's the same. Okay, so there are all kinds of examples we can do with this, and maybe you could even talk at your table a little bit. What's an example of an experiment? And in that experiment, you can say what your explanatory variable is, your response variable, any potential lurking variables, and controls. And so I gave the example here, how does study time affect my science quiz scores? Okay, so let's just kind of talk through which variables are which in this idea, and you guys might come up with other stuff as well. So how does study time affect my science quiz scores? How much time you study, that's your explanatory variable. That's what you have control over. That's what you can decide. Are you going to study for 10 minutes or 20 minutes or whatever? Okay, so maybe you can measure this in minutes, or if you're really, dedicated student, maybe in hours to study more often. The response variable is going to be the score you get on your quiz. So say you did this over a few weeks and you studied time in minutes. And the first week you studied 10 minutes, and then the next week you studied 20 minutes, and then 30, and so on, all the way up to whatever. And then your response variable is your quiz score. And that might be in percentages because it's going to be out of 100, right? So we could do percent, and this will be percent. So all the way up to 100. So let's say if you studied for 10 minutes and you got like a 70, maybe that's right here. So you'd put a dot right there. And then if you, the next time you studied for 20 minutes and maybe you got an 80, and the next time you studied for 30 minutes and maybe you got a 95, and then if you studied for 40 minutes, maybe you got 100. Okay, well then now this is going to max out because you can't get more than 100. And that's what your graph looks like. This is just one example. Now, are there lurking variables here? Absolutely. Because what if your quiz score had nothing to do with how much time you studied, but maybe it had to do with like how good your notes were? Maybe it had to do with like how things are going with your friends. Maybe you had an argument with a friend and you're just thinking about that and like you had trouble concentrating. And so maybe one of these days your quiz score is down there. Like hopefully that wouldn't happen, but you never know. Could it be like the temperature in the room? Maybe you were uncomfortable, maybe you didn't have enough food to eat and so your brain's not firing as fast. And maybe how much sleep you got the night before. There's all kinds of things that could affect this experiment. So this is not a very clean, tidy experiment that's easily controllable. And that's usually the case when you're dealing with human beings. Okay, but what are some things that we could control? We could say instead of having the same person taking the test, we could take the score of every student in the room and having different students do different times and say it's like on the same day, so the same temperature in the room. Let's say we did this at retreat, so like everybody ate the same food. That would be a way to control the experiment. So anything that you can do to take these, a control is like getting rid of a lurking variable by getting it under control. So let's say we were also at retreat and we made sure that every person got the same amount of sleep. Those are examples of controls. Then you might say, well, if a different person's taking the quiz, then you have all these other lurking variables, and that's true. All right, so those are the types of variables that you're going to need to know and be able to explain. Next week, we will do a lab that will kind of help us understand this better. And I hope this video was helpful, and have a great day.